For number 6, we also need to manipulate or think about how we can rewrite this function here given to us, which represents a study of an annual population. And we're asked to think about how could we rewrite that if it's not an annual rate, but instead a monthly rate. So an annual rate is something that's measured once per year, and obviously a monthly rate is measured 12 times every year. So thinking about our new exponential function, we're still going to have the same starting point, right? The initial value is going to be 750 either way. However, instead of having that rate of 1.16 and doing it for every once per year, we need to think about what if we did that in 12 times per year. So we're going to raise that to the exponent of 1 over 12. After that, we know that the number of years, we have to also think about how many times we're calculating it or thinking about that growth rate. It's not just once per year, it's now 12 times every year. So if we crunch these numbers a little further and simplify, 1.16 to the 1/12 ends up being 1.012. And again, we have to put 12t up here because we're not compounding once per year, we're compounding 12 times per year. Or we're calculating that rate over 12 times per year. So that's why we know the correct answer is B. If you wanted to use the process of elimination, we can also think about answer choice 3 and 4 wouldn't be correct because the rate has remained the same. And it asks us to tell it in terms of a monthly rate of growth, so we know it has to be either answer choice 1 or 2. Question number 7 goes a little bit further into the compound interest formula. So Kellyanne has $20,000 to invest. Obviously, the first part is going to be half of that, or $10,000. An annual rate of 0.9% compounded monthly. So as a refresher to the compound interest formula, we'll have the initial amount times 1 plus the rate, in this case, which is 0.9 or 0.09 as a decimal, divided by the number of times that we are compounding, in this case 12. All of that is raised to the rate, or the number of compounding times the number of years. So in this case, it would be 12 times t. So that's the first part of her account that's growing at an annual rate of 0.9% compounded monthly. The second part, the other half of her money, she puts into an account that grows continuously at an annual rate of 0.8%. So we know for that part, we're not going to be having a compound growth rate. We're going to be using, if you look at all the answer choices, kind of a natural exponent, which we didn't learn about, and you won't really need to come up with the answer. Because if you simplify down this expression, which we wrote here previously, you'll come up with 10,000 times 1.00075 to the 12t, which matches up with answer choice number 4. Another clue, or again using process of elimination, answer choice 1 and 2, if we look at the exponent, doesn't include the monthly compounding. It's just multiplying times t, or once per year. But since we're compounding monthly, it would have to have 12t in our answer. And for number 3 there, we'll see that growth rate. That's if you did some kind of incorrect multiplication, kind of a fake out answer. For number 8, we're again asked to kind of think back to the rules of exponents. So we'll start by saying the correct answer is D. D is not equivalent, and we'll talk about why. Again, thinking back to what we talked about before, if we have two exponents here with the same base, if you multiply together two exponents with the same base, you would add the exponents. So this would become 2.7 with an exponent of -2 plus 0.05x. -2 plus 0.05x, that's not going to end up with -0.10x. That's why answer choice 4 is not equivalent. just review why each of the others is equivalent. If we distributed 2 to 1 and distributed 2 to this equation, or this part of the expression, we'd end up with answer choice 2. So since that's equivalent, that's not an answer. For answer choice 2, you'll notice we have a power raised to a power. If you have a power raised to the power, you multiply the exponents. So this would be 2.7 times 2 to the exponent of 2 times negative 0.05x. If we simplify that, that'll be 2.7 to the negative 0.10x. That matches up the same as our original function. Okay, and finally for number 3, you'll notice they've rewritten this exponent, which was negative, with a positive exponent. In math, if you change an exponent from negative to positive, we change the side of the denominator or numerator that the expression was previously. So in the situation, 2.7 to the positive 0.10x is the same thing as our original expression. So for all those reasons, the correct answer is 4 for number 8.